Hey everyone, welcome to day 6 of our derivatives and integrals challenge. So today we're going to differentiate this x to the x function, and so we're going to need to use logarithmic differentiation. Okay, so what that means is we're going to start off by taking the ln log base e of both sides, and then we're going to use those laws of logarithms to make this doable. Okay, so we have the ln of y is equal to the ln of x to the power of x. And then, if you'll remember to your pre-calculus class, there is a log law that says we have the ln of some argument to an exponent. That exponent can go out front. And so now we have the ln of y is equal to x times the ln of x. And now what we're going to do is we're going to differentiate both sides implicitly. And so what that means is we're going to differentiate the left-hand side kind of like we would do some implicit differentiating. And so we're going to take the derivative of ln y with respect to x. And so the derivative of ln of x would be 1 over x, right? And so that means that with respect to x still, because we're always doing dy dx, right? The derivative of ln of y is going to be 1 over y dy dx, right? That's how we always work out our implicit differentiating. And on the right-hand side, these are just terms in x. And so we can use the product rule. So we'll do x times the derivative of ln x. So x times 1 over x plus the derivative of x, which is 1 times ln x. And so all in all, we have 1 over y dy dx is equal to x times 1 over x. That's 1 plus ln x, right? And now what we're after in the end is the derivative, right? After all, we want just dy dx on its own. And so all we have to do to get it is get rid of this 1 over y factor in front of it, which means we multiply both sides by y. We multiply both sides by y. And I'll remind you that we do know what y is. We started with an expression for y, right? Y is defined to be x to the power of x. And so we can sub that right in for y. So our final answer will read that dy dx, our derivative, is going to be y, which again is x to the power of x, times 1 plus the ln of x. And there we go. There is our derivative. Now, for the integral, we're going to integrate this with integration by parts. And I'll remind you of the general formula. The integral of u dv is equal to u times v minus the integral of v du, right? And so this becomes an exercise in intelligently selecting what we want to be u and what we want to be dv. Now, typically, the rule of thumb that kind of guides my process is that I'm going to make u, because the u is going to get differentiated, right? So I'm going to pick a u that when we differentiate it, it becomes simpler to work with, okay? I guess there's so many different rules. I probably shouldn't give general rules yet. Bear with me. So in this case, this is simple enough that we can kind of pick either one. But I do want, generally speaking, I want the u. I know I'm going to have to differentiate it, so I do like the u getting simpler every time. So I'm going to let u be just x, okay? And then I will let dv be e to the x dx, okay? Now what that means is that getting their counterparts, if u is x, then du is simply dx. And if dv is e to the x dx, then that means that v, the integral of that, is going to be just e to the x, right? And so what that does for us is that using this formula for integration by parts, I can rewrite this integral as, this is the integral of u dv. So now I have equal to u times v, which means x times e to the x, minus the integral of v times du. And so that's e to the x for v and dx for du. And so that's the integral of e to the x dx. And this we know how to integrate right away, right? This is not going to be a problem at all. And so that means this integral becomes x times e to the x minus, you know what this is. This is simply e to the x plus c. And we're already done. And so a nice short example using integration by parts for day 6. Hope this helps. So nice practice with logarithmic differentiation, an intro to integrating by parts. This is a technique we use a lot, and they do get progressively more and more difficult. So I hope this helps. If you guys have any suggestions, please let me know in the comments below. And thank you so much for watching.